You've seen the thesis, and now the project is here. We are diving into a multi-tool DIY build that mixes unexpected materials like repurposed election posters with 3D printing from our Sovo, FLSun, and Creality machines, alongside laser cutting on our large 600 by 600 diode and CO2 lasers. The goal? To create a dedicated safety enclosure for our Monport GA60 fiber laser. Instead of buying a pricey commercial box that would increase its footprint, I designed a resourceful solution using affordable parts sourced from AliExpress. Join us as we walk through creating this enclosure, effectively trapping fumes and containing beams to make our powerful MOPA laser much safer to use. Even if you don't own a fiber laser, you might pick up some fun and generally applicable techniques for using unconventional materials and combining different fabrication methods in your own projects. This is Gergo, and welcome to Gergo Print 3D, our YouTube channel all about our DIY adventures with laser machines and 3D printers. You know how we do things. Like all our previous 100 videos, this one also features curated translation-ready subtitles and detailed chapter markers to give you the best experience. Speaking of our laser adventures here on the channel, the Monport GA60 has already featured in a couple of videos. You might remember seeing it first in this video, which served as a tutorial guiding first-time users through the unboxing and initial setup, along with our first impressions of it. We then used it in a practical project featured in this other video, where we combined the GA60 for engraving stainless steel spice jar lids with our Monport Onyx R55 CO2 laser for the glass jars. For those of you interested in picking up one of these awesome lasers, you can find our affiliate links in the description below. By using these links and applying either Gergo10 or Gergo20 coupon code at checkout on the Monport site, you not only get a great discount on your purchase, but also help support our channel's DIY projects at no extra cost to you. So why did I decide to build an enclosure for the GA60 in the first place? Well, while fiber lasers like this do come with eye safety eyeglasses, and you really need one for every person and pet that may step into that room, they typically arrive without any built-in ventilation and have a fundamentally open structure. That means effectively dealing with hazardous fumes and ensuring beam containment is completely up to you. I looked at commercial enclosures, of course, but I found they are often quite pricey, easily $500–600 or more, plus shipping. Beyond the cost, they usually wrap generously around the machine, drastically increasing the overall footprint, at least doubling or tripling the space needed. They also tend to use expensive colored safety plexiglass all around, adding unnecessarily to the price. And even then, you still have to buy and set up your own ventilation fan and ducting. For us, that didn't quite fit neither our needs nor our budget. So I decided to design and build our own custom solution. By going the DIY route, I could create something that achieved essential safety, trapping fumes and containing the beam, but with some key benefits that were important to us. A tight fit that doesn't increase the GA60's footprint. Full access to things like autofocus, flexibility with dual-side venting, and lightweight design. This build involved combining laser cut panels with custom 3D printed parts designed to be printable on virtually any FDM printer using minimal filament, though getting your clearances right is important for assembly. And of course, cost was a major driver. I estimated the main components and materials came in around $100–120, a massive saving compared to those commercial options. Just note, this price doesn't include the inline fan or exhaust hose, because commercially available enclosures typically don't include those either. As for the time, assembly took us about 2–3 hours after everything was cut and printed. My large diode laser spent about an hour laser cutting each of the 7 main panels, but honestly, these could also be hand cut if you're up to a bit more effort. If you're finding this DIY approach helpful or appreciate finding ways to save some cash on useful tools, please give this video a like. It really helps the channel. So what exactly do you need to build this enclosure? I started with materials many DIY workshops might already have lying around. The largest volume material was corrugated sheets, repurposed from old election posters I collected after the elections last year. Basically free. I doubled up these sheets for the walls mainly to try to hide the poster graphics, though you'll actually see later that with the light inside, they will still show through a bit. It's actually nice to see opposing parties work together for safety here. As an alternative to the corrugated posters, you could easily use thin plywood for these sides and top panels instead. If you use plywood, they are stronger too. You likely wouldn't need to double them up. I also used some thicker scrap 4-5mm plywood we had for the base, back, and front top frame pieces, and a bit of duct tape, another workshop staple, and under 300 grams of cheap PLA filament for the 3D printed parts I mentioned earlier. And that covers a good portion of the build. For the structural components and features, we sourced everything from AliExpress. This included 4 2020 extrusions for the corners, about 20 corner brackets with T-nuts, and all the necessary screws. We also got a safety window, specifically polycarbonate for laser safety, a bright cob LED strip for lighting inside, and an inline fan for the crucial ventilation system. All these components sourced from AliExpress allowed us to build this enclosure very affordably. If you're looking to build one yourself, you can find direct links to these specific items on AliExpress along with their current prices in the video description below. And make sure to check out our special coupon codes there too. They can help you save even more on top of AliExpress's already pretty good prices. Now about how this enclosure came together design-wise. As you might have noticed in some of the earlier background shots, the initial modeling and planning all happened in Autodesk Fusion. Laying everything out digitally and seeing how the components were supposed to fit together is one of the most satisfying parts of a project like this. From Fusion, it was over to Lightburn to generate the precise cut patterns for the main laser cut panels. Honestly, I was incredibly lucky. Almost everything actually fit perfectly right on the very first attempt in real life. There were just a few small components that needed minor adjustments during the assembly process, but thankfully, these didn't require recutting or wasting any material. And of course, I've made sure to update the published models with these necessary tweaks. So if you're looking to build this yourself, all the design files are available for you. We've put together a project on Cut3D containing all the STL files for the 3D printed parts and the Lightburn cut patterns. You can find the link to that Cut3D project right down in the video description. First up, preparing the panels. I cut the main pieces on our large 600 by 600 millimeter MagPow X5 22 watt diode laser. That open frame machine from geekbuying.com that we usually use out on the porch. Our review video covers this laser in detail if you're curious. Cutting corrugated plastic like these election posters was actually pretty tricky because of the double layer and the vertical walls inside. It really needs very slow, quite high power passes. And a super important tip here is to use your air assist at its highest setting to stop those plastic fumes from fogging up your lens. And this material is likely toxic, so ventilation or fume extraction is really essential. While I was laser cutting those panels, I was also fabricating the 3D printed components in parallel. These included pieces like the venting duct adapters or connectors, spacers, and cable lining. I initially tried printing the adapters on our FS on S1 Pro. Man, that printer is incredibly fast. My review covers this unique Delta Motion machine if you want to check it out. However, these initial prints had some clearance issues. While I tried my usual boiling water trick to help them fit in a softened state, The best path forward was just to reprint them using the then new K2+. It just doesn't have the subtle dimensional accuracy challenges sometimes intrinsic to Delta Motion systems like the S1 Pro. But honestly, you don't really need huge or fast printers for any of these parts. And working in parallel for the smaller pieces like the spacers and cable lining, I used my new favorite assistant printer, the Sovol Zero. Its tiny build volume and quick printing speed are perfect for these smaller jobs, making it my go-to for those kinds of side tasks present in any complex project. I reviewed this little workhorse about a month ago if you missed it. With all the parts cut and printed, it was time to put everything together. Assembly started by building the side panel assemblies using 3 M5 screws and T-nuts on each side to secure 2 of the corner extrusions to the panel. I then connected the right half of the 3-piece rear panel to that side assembly. Of course, I did exactly the same for the left side. Then I could add the third piece with the special locking mechanism in the back to connect the 2 halves of the rear section. This is necessary to work around the fiber cable, which of course cannot be disconnected to install the enclosure. We drive these 3D printed spacers onto the M5x20 screws with the Hato electric screwdriver. These slide into the keyhole slots I cut in the middle piece of the rear panel, creating a simple yet effective locking mechanism to firmly hold the 2 sides together. Next, I started installing the internal side panels and features. This involved securing the LED strip to the inner piece of the doubled up side panels, using zip ties to hold it in place, and then adding the 3D printed LED cord lining to keep the wires tidy. After that, I slid the inner walls into position, politicians facing each other, and made sure everything was properly aligned before adding the top. Adding the top panels requires installing the corner brackets first. I quickly discovered the alignment protrusions on these little brackets were in the way and had to be sanded down to fit cleanly, which was easy enough to do with the precision rotary tool Hato sent us recently. For our experience with the other 2 components of their snap block system, see our previous video. Once the brackets were on, adding the top panels was next, which was a little tricky due to the tight angles for accessing some of the screws. After the main top structure was in place, I installed the venting duct adapters, placing the open one on the right side where our ventilation would connect, and placing the covered one on the left side, which makes our design future-proof and allows for having the ventilation from the other side later, if needed. With the upper assembly largely complete, it was time to mount it onto the base frame. This base frame is thin, but being cut from the same 4mm plywood as the back panels, it gives a bit of stability to the still wobbly structure at this point. Mounting it on the base frame also starts with attaching 10 corner brackets similar to the top. I noted that these also had the same alignment protrusions that needed a quick sand with the Hato rotary tool. Once the brackets were in place, I carefully lowered the upper assembly onto this base and secured it using the bottom brackets and the final set of M5 screws. Finally, it was time for the moment of truth, installing the completed enclosure onto the Monport GA60 itself. I carefully lifted the enclosure and positioned it over the laser unit. I secured the back section and then had to do a little fine-tuning on the sliding back cover to get a perfect fit around the back of the laser arm. That definitely took a couple of takes to get just right. The last structural steps were adding the safety window into the front panel. It slides neatly into the grooves of the front 2 extrusions. This was one of my early visions for this project. And then connecting the inline duct fan to the venting adapter on the right side. I also added a simple window stop mechanism, just a drilled hole and a long screw to prop the window up when opened. After getting the enclosure built, I ran into a couple of adjustments I needed to make. First, I found that the opening on the rear panel didn't quite allow the laser arm to go low enough for the autofocus to work correctly. Fortunately, this was a simple fix, easily done by slightly trimming the back panel pieces. We only needed to add about 15 millimeters to the range of motion. Since I already packed away the MagPow, and it was getting dark and cold on the porch, I was really happy to have the enclosed Montport Onyx R55 CO2 laser right here in the workshop. It's great for cutting plywood, and these rear panel pieces fit perfectly into its smaller work area. Its camera was also a huge help for making precise adjustments to these existing pieces. Initially, I actually hadn't designed to add a front top panel over the safety window, even though the colored plexiglass I got from AliExpress was slightly shorter than the total height of the enclosure. This was another small piece that fit easily into the Onyx R55's work area, and I appreciated its camera-aided ability to precisely cut the piece from a scrap of wood, only slightly larger than needed. As you might notice, I took the opportunity to also engrave logos and some warning text onto this panel, which will lead us right into the next important chapter of this video about my concerns and some disclaimers regarding this project. Adding this panel strip to the top of the front of the enclosure greatly increased its stability, completely taking away that slight wobbliness it had originally. But before we get to those disclaimers, there was a pretty significant design flaw I really wish I had thought of and fixed earlier. The safety window is made of polycarbonate, which is easily scratched or marked by other plastics. The way I designed the top, the edge of its plastic panels could actually rub against the safety window as it was moved up and down when opening it. I'm not totally sure if it's really scratching or just marking, but after just a few times opening and closing the front window, it had gathered a good number of scratches or marks I haven't been able to remove with any solvent or polishing method I've tried. My workaround was to add 2 screws, one on each side, to push the window away from the edges of the top panels. The screw heads might scratch the window as well, but it's much less of a problem right on its very edges. An even more important addition was a piece of silk fabric along the edge of the top panels to create a smooth contact with the window. Be sure to add these before you ever slide the window in. And now let's talk about some of my potential concerns regarding the enclosure, as sort of hinted at by the warning text on the front. Although it features what's advertised as a laser safety window, which I specifically purchased for the 1064 nanometer wavelength of my fiber laser, the piece of colored plastic I received did not come with any certification. It's from a company that seems to specialize in making laser safety equipment, but they don't appear to be certified in the EU or USA or any other major markets, and there's no marking on the window itself. While it probably adheres to the OD6 Plus protection level they sell it for, I personally would not fully trust it with my eyesight alone. So we've gotten into the habit of still wearing our certified laser safety glasses when the laser is operating. This is even more important since I haven't done any research or have any information at all about the laser blocking ability of the corrugated plastic panels either. They definitely let visible light through, so I'm not sure if they diffuse the laser beams enough to become harmless in case of a reflection. Better safe than sorry, so the safety eyeglasses stay on. I have just a few last points which are less critical. First, unfortunately, the LED strip I got does sometimes flicker on camera. Sometimes it doesn't, but I haven't yet figured out what causes this. So if you're planning to film your laser projects like I do for this channel, maybe look for a flickerless light source. Second, Montport promised to send a rotary accessory for this laser, and I hope it will fit inside, but honestly, looking at pictures of the rotary tool, I'm afraid it might not. I'll definitely update you on that when it gets here and I can test it. Third, an interesting Differentiating feature of Monport fiber lasers is their ability to rotate the laser arm to the side of the device to engrave or mark objects that wouldn't otherwise fit in the regular work area. With the enclosure on the device, we won't be able to utilize this feature. However, it is fairly easy to remove the enclosure, either for using the arm rotation feature or if that rotary accessory ends up needing the extra space. It's important enough for our channel that I'll mention it again. If you got value from this video or just enjoyed seeing this project come together, please give it a like. Thank you if you already have. So with this custom enclosure, the GA60 MOPA has truly found its permanent place in our little workshop. Being able to mark metal, plastics and other materials so effectively is absolutely key in a DIY studio like ours. The GA60 is powerful, versatile, and now with this enclosure, it's not only easier, but also much safer to use. We've been really happy with both our Monport Onyx R55 CO2 and this fiber laser system. Whether you're thinking about their most premium MOPA offering or one of the more affordable options, Monport is definitely a great source for laser devices. You can use our links in the description to look around their page, and when you're ready to order, be sure to use our codes GERGO10 or GERGO20 for the best possible prices. And speaking of what's next, we are already working on a follow-up video where you'll see this laser and its new enclosure in action as we customize various blanks from Creator Rally and AliExpress, showing you some great business opportunities. But we also keep improving our 3D printers. Coming up next, we are planning a tutorial on leveling the bed of the Sovo Zero, or maybe a surprise video on Sovo's newest wonder, which I'm not even allowed to talk about yet. Then I'd like to tell you about a super unique experiment we are doing controlling the humidity in our printer room, so we no longer need to worry about our filaments getting wet. And I haven't forgotten about that must-do mod for the Creality filament system on the K2 Plus or High Combo. But it's not just Creality, we are planning to add a multicolor option to one of our Sovo printers too, using CoPrint's KCM, which is already here. And you'll see us utilizing our GDQ1 Pro's heated chamber to print thin and strong ABS parts for a versatile phone holder we designed. Plus, we'll be sharing our longer-term experience with the Hotto Precision toolset we debuted in our previous video. There is honestly so much coming. We really hope you are subscribed so you don't miss any of these projects. And if you haven't seen that last video on the Hotto tools, be sure to watch it next, because our 3D printer and filament giveaway in collaboration with Gtech is still on. Being a tiny channel, your chance of winning is incredibly high. So click here to watch that, or check out our playlist of our Monport laser videos right here. But most of all, go print 3D. Thank you for watching yet another Gergo Print 3D video all the way to the end. Be safe.